And from this slide, we can see the nitrous oxide is constantly rising. And we probably never thought about this before, but the use of fertilizers also contribute to generation of this gas. The last one I want to mention about the greenhouse gases is CFC, chlorofluorocarbons, which is widely used as a refrigerant in refrigerators and air conditioners. The amount is very low, but the effects are very big. They are 15,000 times more efficient than carbon dioxide, especially at retarded, like keeping the heat loss. They are 15,000 times more. When CFC was eliminated, there's other chemical substitutes like HFCs. They also have this property of keeping the heat, which is thousands times higher than carbon dioxide. And those compounds are completely synthetic compounds. This is why I want you to pay attention to the video at the beginning of the chapter and why these chemicals hurt the ozone layers, right? And after we phase out, we ban those chemical production, the ozone layers start to repair themselves. And until today, it's very close to before the big holes appeared. A major cause of ozone depletion, and those chemicals were scheduled to be eliminated by 2020. So those are the four major players of greenhouse gases. What is our current state of knowledge about climate change? I know this is a little bit confusing, but previously we talked about what we observed, and we have evidence the globe is warming and carbon dioxide is rising. And I want to go more in details. What is the current state of knowledge about climate change? So the IPCC, which is a panel on climate change, was established in 1988. That's about the time we realized about the global warming. And this group of experts is organized into several working groups. One is focusing on physical science that relates to climate change. And the group 2 deals with impacts of climate change. And the group 3 deals with how to mitigate the effects of climate change. So they have different purpose and goals in dealing with climate change. Again, one group is gathering the knowledge, the other one is studying the effects of those factors, and the third one is aiming at how to reduce the effects. So they have the report from the group 1, okay? So this is the current state of knowledge. Human activity is clearly influencing climate, so we should be mainly responsible for the climate change. Carbon dioxide is increasing, and it contributes to increase of the global temperature. The evidence of increased temperature is very clear. Since 1880, overall, the temperature already increased between 0.65 to 1.6 degrees Celsius. You may feel nothing about this change, but this is later on we'll discuss how small change can trigger in motion big changes all over the planet. So snow and asphalt in northern hemisphere is reducing, and the snow melting earlier. We have more cold days. We have more cold days in some area of the planet, and some other area we have more warm days. And ice is melting, and Arctic warming more than ever before, and the permafrost is melting. Overall temperature increase is 2 to 3 degrees Celsius, and the glaciers are melting. And thinking about the oceans, oceans store a lot of energy and restore a lot of heat in the water. It affects the carbon dioxide level and the pH of the water also. So there's overall about 28% of carbon dioxide ends up in ocean. So it is I would say this is a big carbon sink in nature. And water pH increase because of dissolving of carbon dioxide in the water, and because of this tremendous energy stored in the oceans, we observe in the upper layer of the ocean, there is a temperature increase of 0.5 degrees Celsius. And of course, sea levels increased about 20 centimeters between, in the past, I would say in the past century, okay? And we have 3.2 millimeter per year increase between 1993 and 2010. Overall, you probably think this is all very tiny, small changes. But if it is happen on a global range, it will bring tremendous change in the climate. The consequences, of course, we went over the evidence of all the data, scientific data. Now, what is the result of those small changes? This is what I want to emphasize. A small increase in the temperature may seem trivial. However, such an increase should set in motion changes that could significantly alter the climate of major regions of the world. So 0.5 degree or 1 or 2 degrees seems nothing in a single home on a particular day, but overall, if it's accumulating, it's happening on a global scale, it will bring tremendous effects in the climate. So we observed the changes to hydrologic cycle, sea level, human health, and the survival and the distribution of organisms, and the use of natural resources by people. Okay, so this is the overall consequence. And furthermore, some natural ecosystem or human settlements will be able to withstand or adapt to the changes while others will not. So some of the areas suffers more than other area, right? Some of the area is a little bit resistant, but other areas suffer are more vulnerable to this climate change, such as coastal area, such as Arctic area. And the poorer countries are generally more vulnerable to the consequence of global warming. And the major risks could be flooding, severe weather, death and illness, food insecurity, agricultural productivity, loss of marine coastal ecosystem, loss of terrestrial and freshwater ecosystem. So we are losing our ecosystem due to this seemingly very naive, very insignificant, tiny change of temperatures. And the first thing I want to focus here is disruption of the hydrologic cycle. Hydrologic cycle is driven by energy, and we discussed this before, right? Driven by sun. And the evaporation, precipitation, water flow, groundwater, all the movement is driven by energy. And the primary source of energy is the temperature of the earth. So when temperature changes, the dissipation of energy changes too. So a change in the Earth's temperature is expected to change weather and the climate. Now, I want to discuss the difference of weather and climate. As to global warming, climate change, those two terms you think very similar, but they're very different. Same here, weather and climate, they have similarities and they have difference also. Weather includes short-term activities, rain, snow, clouds, winds, and the climate is a long-term average of weather patterns. So first, probably the weather changes, and then that leads to the climate change.